Hello everyone. Today I want to discuss some BGP convergence stuff, especially large-scale BGP design and convergence characteristics of the distance vector protocol, Bellman-Ford protocols, let's say. Probably you heard before BGP Path Hunting, right? So we will understand BGP Path Hunting and the effect of BGP Path Hunting to the convergence, and I will show basically all this process. First, I will explain the problem situation, but then we will demonstrate also lab, and we will understand the convergence characteristics of the large-scale networks. We will mimic one CLOS topology. We have here just a three-tier CLOS topology, so leaf and spines, but I will also explain when we would have 5 tiers. So let's say here leaf and spine, if there would be super spine, what would happen, etc. First, let's go through the recommendation for using BGP in large-scale environments such as large-scale data centers, okay? So for this, we have RFC, by the way, RFC 7938, and you can find some videos about RFC 7938 and design and deployment recommendation with that RFC in the YouTube channel as well. So you can find a couple videos actually, and some real-life deployment videos as well. You will see, I think, 2 or 3 videos there, different data centers. One was a financial network, another was just, I think, hosting company provider, etc. We were discussing, right? So first, let's remember what RFC's ASn allocation schema was suggesting. ASn, autonomous system number allocation, for this kind of data center, and why they are suggesting in this way. And then I will not set up that way. I will set up my lab in an opposite way. So I will show you the problems if we wouldn't follow this methodology, and what would be the advantage of this recommendation also we will try to understand. While we are doing this, of course, there will be many things, maybe for some of you new things in BGP, specifically BGP ECMP, BGP convergence, BGP Path Hunting. What does it mean? Many people actually knows probably Path Hunting in different ways. We will go through and hopefully we will enjoy. Now, if let's say our topology, 5-stage CLOS like this, let's say here, top of rack, leaf or spine, or leaf, spine and super spine, whatever you name it. We have 2 pods. For simplicity, of course, you might have multiple pods in your data centers, right? So the recommendation is, in a pod, or cluster you can call it, we have on the top of rack or leaf here, we have unique AS numbers, they suggest. Unique AS numbers. By the way, I am going through with a 2-byte ASn schema. 2-byte ASn, as you can see. With the 2-byte ASn, private range is limited to 1023 ASn. With the 4-byte ASn, we have 90 million, so we have so many, but let's say we are limited to use 2-byte ASn, so private range is 1023. And we could use public, but another videos you can see why we wouldn't use public ASNs in 2-byte ASn schema in our data center, etc. Now, my examples is private ASn 2 bytes. Here, the recommendation, as I told you, unique AS on the top of rack. Then, same AS number. Here, this is very important. Same AS number within a pod in the spine layer. Same AS. But across the pod on the spine, we have different. Again, always the top of rack is unique AS, and let's say super spine layer here, all same AS number. Actually, using here same AS number and here same AS number because we want to eliminate path hunting. When I go through, path hunting will be very clear, especially when I demonstrate the lab. It will be very clear why we don't want to have path hunting. You will understand. But if I tell you at the moment, just as a hint, if I give you BGP's path hunting is very similar to RIP's count to infinity, so you probably get the idea. You don't want to have that, and you want to avoid as much as possible. So that's why here the recommendation is what? Using in a pod same AS number on the spine. In my lab, I will not use 3-tier like this, but 2-tier for simplicity, okay? And there will be leaves and spine. And again, I will follow, normally I would follow the recommendation and use unique AS on the top of rack, so different AS on the top of rack. And then, or let's call it leaf, spine, and super spine. Let's go through that terminology. So I don't follow the recommendation. I will use same AS everywhere. Huh? And also, recommendation was what? Use on the spine layer same AS number. But I will also deviate from the recommendation, but I will use unique AS, and we will see how path hunting will be a problem. If I would use same AS on the spine, we wouldn't have path hunting, then convergence would be faster. And I will demonstrate those things, okay? Sure, so let's explain now. So but you understood the problem space, right? That's important. The idea, you are using here unique AS and same AS on the spine. So when this, let's say, leaf send the prefix, it will go to both of the spine, and then spine, when they send to another guy and they send back, spine will not allow because AS path loop prevention, right? If I see my AS number in the AS path, I will not accept it. That's why you are using here same AS, so you don't receive the prefix from another leaf. It's called also valley routing, so we don't want that. But in my topology, I will accept that because I will not use same AS number on the spine layer. Let's go through the topology. Hopefully it will be more clear. So this is the topology. I use here 6 lift switches and then 3 spine layers. So 6 lift, 3 spine. It could be, of course, now you will see the problems. I will show you the routing tables, BGP routing table as well, local RIP, etc. But imagine you would easily have in the large-scale data center like 32 leaves, maybe 8 spines, and you will see path hunting how it can be a big problem if you have larger design. Now, let me explain a little bit what we have here. 6 leaf, as I told you, and 3 spine. And then on each and every leaf, I have loopback interface 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, etc. It goes like that. And BGP neighborship between, these are, by the way, same AS number as I told you. Normally in the RFC recommendation, it should be each and every of them unique BGP AS number, right? But I use same AS number everywhere, same AS. So then, because I want to show you the path hunting, but by the way, even if this would be unique AS everywhere, if on the spine I wouldn't follow the recommendation, and if I would use unique AS on the spines, still we would have the path hunting problem, but I wanted to multiply the problem. So, okay, here, each and every basically spine also have unique AS, okay? So this one AS70, AS80, AS90, R7, R8, R9, but everywhere on the leaf layer, I am using same AS number, AS10. Let me show you. These are my routers. R1, when I check that, as I told you, I create a loopback interface for the neighborship, 1, 1, 1, 1, R2 will be 2, 2, 2, 2, etc. And then from the loopback to loopback, I created BGP session. Of course, since each and every of my leaf is the same AS, like AS10, and then leaves are different AS70, 80, 90, from leaf to spine, we have eBGP neighborship. By the way, there is no any physical or logical connectivity, any physical or BGP connectivity between the leaves or between the spines, just leaf to spine. This is classical CLOS topology. Okay, so these are eBGP, as I told you, okay? And we are using on the leaf AS10, and then spine unique AS70, 80, and 90. So if I then check on R1 or any of these leaf, we should see 3 BGP neighborship, right? To all of those spine, I should see 3 BGP neighborship. So if I would check that, I will see, as you can see, 3 BGP neighborship, okay? And also what I did, I created on R1, not loopback 0, loopback 10, another loopback interface, 11, 11, 11, okay, here. And if you will check also one of those spine, as you can see, I will have, since I have 6 leaf switches, I need to see 6 eBGP session. As you can see, all of them there. Okay, 1, 2, 3, 4, 5, 6. All of those leaf switches are there. Now, what I should also see, if I would advertise that loopback 10, 11, 11, 11, 11 interface on R1 to BGP, I should see in the BGP 11, 11, 11. So I am looking here, right? If I advertise 11, 11, 11 here, what I should see from R1, I should see 11, 11, 11 on R7. But it should come from R1, right? It's coming not just R1. It's coming from every leaf switches actually. Huh? Yeah, this is the problem. This is problem. Why? Because all other paths are incorrect paths actually. Okay, so if I lose that 11, 11, 11, which is connected to R1, normally I don't have from R7 to, if that loopback goes down, this is the primary path it chooses, of course. If you see primary path, it shows here 1, 1, 1, 1, because next, as you can see here, what? AS path, shortest AS path will win. Ah, by the way, I am seeing from 2, 2, 2, 2, 3, 3, 3, etc. 10, 80, 10, another path. How it happened? 10, 80, 10. Let's see control plane how it works. If prefix come from here, that 11, 11, 11, it sends to all those 3 spines, right? Over here, over here, over here, because eBGP neighborship I have. Then all those spines will send back to other leaves, but other leaves are using same ASn. So what I did on each and every leaf, I did allocation. Otherwise, they wouldn't accept the prefix in the first place. So if we will check just R3, let's say BGP configuration, you will see allocation on each and every leaf, of course. Okay, as you can see, allocation from each and every spine. So I accept that, and after I accept, what should I see? Each and every leaf from each and every spine actually receive also that 11, 11, 11. Then they should all reflect to R7 back, right? This guy. And they should also reflect. So they are receiving and then they are reflecting also to each and every spine. Yeah? So that's the case. And I was thinking, okay, should I see then through here best path, but if that loopback goes down on this guy, I need to explore all the other paths as well, like this path, right? And then this path, all the other paths actually, I need to explore. And we call it path hunting because the other paths are incorrect paths. Okay? If that interface goes down, and if I am exploring each and every other paths, basically convergence will be much slower until R7 learns from the control plane, all the withdrawn etc. will be sent, and until control plane converge and R7 finish the exploration of each and every path from each and every leaf, it will not advertise, for example, to the upper layer. Let's say this is leaf spine and then super spine. As I told you, for simplicity, I didn't draw that. R7 will not advertise to other guys that I don't have reachability anymore. So traffic normally would be black holes on R7. Okay. So that's the idea. And by the way, as you can see, allocation I showed you. But let's check again. Here what I'm seeing, all these next hop. And I was thinking on R7, will I, okay, from here, one AS path. But then will I get from R2, two of those other spine in the path. Then R3 also two of those other spines. So will I get number of paths to explore those for the path hunting? How many paths I will explore? I was thinking, and I decided to show you also. Will it be multiplied by the leaf and the spine switches or what? How many paths normally I would extra receive? And what I am showing you here now, we need to go to R2 for example for that, or any of those leaf switches. Let's go to R2 and check what's happening in the BGP table of R2. As you can see, R2 and all the other leaf switches like R3, if you go through, R3 also will receive the 11, 11, 11 from three of those, right, devices. And what is a regular BGP speaker it should do? It will do best path selection. And based on the best path selection, it will decide one of them as best. And it will reflect to R7 back just one of those paths as the best. Okay? And each leaf will do that. That's why R7 from R1, it will receive with the one AS path length and it will be best. And then from each and every of those leaf, although those leaf has, as you can see, three paths, they will select only one of them and they will advertise only one. That's why spines will receive one from the original place and also extra path, one extra path from each and every leaf. You can see, because on this leaf, although you have other spines path as well, right? Prefix comes like this and then comes to this one and then here, right? Or comes to this and then this and this, or comes to this, like this. So many paths, but how many you will see on the spine layer, based on the number of leaf switches basically you will receive. So you will not multiply with the spine because leaf switches will do best path selection and it will advertise only one best path. Then I thought, okay, on R2 leaf switch or R3 or any of those leaf switches, if I would use add path for example, right? So three spine I have now, right? Three of those spines are sending me. If I would send all those three paths to R7, then I would basically receive total paths as what? 2 multiplied by 5, 10, and one original 11 paths instead of total 6, right? But add path will not work on the eBGP neighbor. Then I thought, what about shadow RR? So diverse path. And again, for the diverse path, I should be the route reflector. So again, iBGP network, not eBGP. So basically, you will end up with having on the spine layer for path hunting based on number of leaf switches, guys. Okay. So, but of course, this is a problem because, as I told you, if you wouldn't see those other next stops here, other paths, in case that 11, 11, 11 goes down, the topology would converge much faster. Let me show you. By the way, underlay IGP, I didn't configure BGP neighborship on the physical interface, but loopbacks, so I use EIGRP as an IGP to advertise those loopbacks, etc. Okay, between each and every leaf and spine. Now, what we can do, for example, let's go to R7 again, check BGP, it's there, 11, 11, 11 behind R1 is coming with the 6 different leaf, you know that. And let's, where was that? Loopback 10. And let's go to loopback 10. Before that, let's enable, for example, debug IP routing. Fine. Let's shut down that interface and let's see what will happen. Shut down. Okay. Oh, something happening. Basically, R3 is placed as a best now from this one. I can see. Huh? R1 I lost. but I need to explore the other paths, and I'm not converging. I will wait. The other next hop will be tried, will be examined, and it will take a lot of time. We can we make it this process faster? We can play with some timers for sure. And now 5555 is the best, it says, as you can see here. Okay, so 333 is gone, examined. It's now 5555. Though we lost that loop back, it's not there anymore. Huh? This is like what you would see count infinity in RIP. And after some time, 2222, or maybe it will just delete the path, and then finally it will converge, and R7 now it's gone. Delete subnet route, as you can see here. Now if you check show IP BGP, nothing is there. Okay, but it would take a lot of time to basically converge. Many things can be done. Don't, for example, allow ASn comment on the leaf switches, so you wouldn't receive in the first place those 6 updates, right? So on R7, let's bring that interface back. So let's get again those 6 paths from the R7 point of view. When it comes back here, let's see those 6, and then we can remove from those leaf switches allow ASn. And what we should see here on R7, just R1 is the best path, and basically, which is the only path anyway, because that host is connected to R1. If it would be, for example, not lots of questions can be asked here. If there would be host dual home to here, and for that host anyway, we could do ECMP anyway. And ECMP is not considered as path hunting anyway, because it's correct path, not the incorrect path. And lots of things, I mean, if you don't ask while I remember, I can talk. If it's one path, not all other leaf for the path hunting, if it's just one, if I am receiving, so I will put no allow ASn. Basically, I will remove that allow ASn. So I will receive only one path. Now I can play with the convergence a lot. I need to make sure BGP next hop tracking is there. So if I lose next hop, IGP should update me so I can have fast convergence. Otherwise, BGP scan timer 60 seconds, you need to wait for that, etc. And I can reduce even trigger, I think trigger delay for by default 5 seconds. I can reduce it to 1 second, etc. I can make it even faster as long as, or I can create BFT session, of course, for different type of failures. And I can track, basically, if I can reach to that device with the BFT, I can have even shorter convergence time. So I think it's came back now. Again, 6 next hop, loopback enabled here. So if you just start typing, like for example on R2, right? On R2, if I, by the way, let me see my BGP again. So I was placing allow ASn, as you can see, towards my BGP neighbors, router BGP 10. So let's say no neighbor 7777 allow ASn, and then 8888 and 999. I think now should be fine. Yeah, allow AS gone. Now if we check what will happen, I don't have any more R2 as the next hop, because when the update comes from R1 to R7, and of course not R7 only, R1 will send all of those 3 spine, and spine will send all of the leaves. But when R2 receive, let's say R2 receive from R8 spine 2, it will not anyway accept, because it will see that, in the AS path I see AS10, which is my AS number, so I shouldn't accept that. That's why it cannot reflect back to spine 1. That's why you don't see on the R7. If I do that no neighbor 7777 blah 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 allow ASn, basically if I cancel on each and every leaf, at the end I should only see 11, 11, 11, 11 with the next hop 1, 1, 1, 1. Okay? And then convergence will be much faster. Do you have any question? So in this video, I wanted to explain BGP Path Hunting and how it would basically contribute, or it would increase the convergence time, and how we can avoid basically path hunting. Okay. The normally recommendation of the RFC is what? Use unique AS on the leaf switches. If I would use unique AS on the leaf switches, right, what would happen? Let's say unique AS here and unique AS also on the spine. Oh, yeah, again, you will end up with the path hunting. Why? Unique AS. So let's say AS 10, 20, 30, 40, 50, 60, and then up 70, 80, 90. 10 comes here, sends to each and every spine. Then when spine send to R2, let's say, R2, what it will see as a path, 10, 80, and then comes to here, 20, and when it reflects to R7, R7 is 70, so totally different AS numbers, R7 will accept. So R7 again, if unique AS on the leaf, unique AS on the spine, R7 would accept all of those announcements, so path hunting will be again an issue. That's why RFC, what it says, not only unique ASN on the leaf, but also same ASN on the spine. If same AS on the spine, then you will avoid the problem. Why? Let's say 10, 20, so unique AS on the leaf, same AS on the spine, it was saying, right? 10, 20, 30, 40, 50, 60, but here, let's say all of them AS 100. So 10 sends to all those three AS 100 guys. Let's say 10 come here, then AS 100, come back, unique AS 20. When it goes back to another spine, it will see as path as 10, 120, but my AS also 100, so that's why I should drop it. Since it will drop, it will not accept. You will not see on the R7 none of those leaf as the next hop anymore. So just one path you would end up if you would follow the recommendation, which is using unique AS, different AS on the leaf and same AS on the spine. Okay. Any question? I think it was short and explanatory video. So for the other BGP and many other topics, continue to follow us.